Hi, Gio. This is lesson 5 on factoring. So you did a lot of factoring last year in algebra, and you're going to do a lot more next year. So I just want to do a little review and do some geometry problems that involve factoring. This is a long video, so if you want to do it over 2 days, that's fine. I think once you get the idea of factoring, after we do a few problems together, pause the video and try some on your own. So basically, when you're factoring, you're always going to look for the greatest common factor. We call that the GCF. So the GCF is the greatest common factor. It's a number or an expression that can be divided into each term evenly. So it's a number or expression that can be undistributed to every term in a problem. So if I look at 4x to the third minus 12x squared plus 4x, each of these terms are all divisible by 4. The first term, the second term, and the third term are all divisible by 4. They also are all divisible by x. So it's basically what they all have in common. They all have a 4 in common, and they all have an x in common. So that's what you're going to factor out. This 4x in front is the greatest common factor. All right. And then it's basically what's left. You're dividing 4x from 4x to the third, and you're left with x squared. You're dividing 4x from negative 12x squared. So negative 12 divided by 4 is negative 3. X squared divided by x is x. And then you're taking 4x and you're dividing it by 4x. You need this placeholder, this 1. These arrows are showing you that you can re-multiply this out and get back the original expression. So the factors, these multiplied, the product of these equals that expression on top. And the arrows are showing you 4x times x squared is 4x to the third. 4x times negative 3x is negative 12x squared. And 4x times 1 is 4x. Same thing with this second example, negative 15a squared b minus 18ab squared. So I look at the numbers first. What number can go into negative 15 and negative 18? And then I'm looking at the letters that are there. I'm just looking at this, and there's a mistake in that. So let's fix this up. All right, I'm not sure why we have this here. Let's change this to a 30, okay? And that should fix the problem. I'm not sure what they were doing there. So let's change this to a 30. Okay, so I'm going to change that up. So what number's in common? 5 is in common. All right, so I'm pulling out a 5. And also look at the A's. They each have one A, so that's in common, and they each have one B, so that's what I pulled out. So I'm dividing out negative 5AB from this expression, and I'm left with 3A. I'm dividing out negative 5AB from this expression, and I'm left with negative 6B. So fix that on your paper. Okay? So in this first exercise, we're just going to write each of the following binomials as the product of the binomials GCF and another binomial. So look at the numbers. What number do each of these have in common? And also look at the letters. What letters in common? Okay, so the number that's in common is 3, and they each have an x. So I'm going to pull out a 3, okay, and then I'm going to write in parentheses it's what's left. So you have to think about if I divide this by 3x, I'm left with x. If I divide the 6x by 3x, I'm left with 2. And you can actually re-multiply it out if you want to multiply this. 3x times x is 3x squared. 3x times 2 is 6x. So you can check all of these just to make sure that you got them right. B, I have 20x minus 5x squared. Again, what number does 20 and 5 both have in common? And that would be a 5. And then what letter do they each have in common? And that would be an x. So I'm going to factor out a 5x. Now, when I divide 20x by 5x, I'm left with 4. When I divide negative 5x squared by 5x, I'm left with negative 1x. Why don't you try C, pause the video, try C on your own, see if you can come up with a number that's in common and any letter, if any letter is in common. All right, so 30 and 20, the number that they have in common is 10. This first term has an x squared, but this does not have any x's, so I can only pull out a 10. That's my greatest common factor. So I'm dividing both terms by 10, and what's in the parentheses, what's left? 30x squared divided by 10 is 3x squared, and negative 20 divided by 10 is negative 2. All right, so that's the first kind of factoring. The second kind of factoring is factoring the difference of two perfect squares. So a perfect square is any number or expression that can be expressed as the product of two equal integers. Examples like 1, 4, 9, 16, 25. We talked about perfect squares when we were doing those radicals. And also any exponent that's even is also a perfect square. So I'm going to factor the difference. Remember, difference means to subtract the difference of two perfect squares. We can always factor the difference of two perfect squares as conjugate pairs. A conjugate means two binomials that are the same, but with opposite signs in the middle. So x squared minus y squared is the difference, because I'm subtracting, of two perfect squares. X squared is a perfect square and y squared is a perfect square. So the way I factor this, I set up my two sets of parentheses. X times x is x squared. Y times y is y squared, and one of these is a plus and one of these is a minus. These are called conjugate pairs. All right, so that's what we're going to do down here, but we're going to add in some numbers. So x squared and 9 are both perfect squares. Put the x and the x in the first position. 3 times 3 is 9. One's a plus, one's a minus. It doesn't matter if you write minus 3 plus 3 or plus 3 minus 3. But that's the basic idea. How does it get more difficult when I have fractions? You have each of these numbers, the numerator and the denominator is a perfect square. So the square root of 4 is 2, the square root of 81 is 9. So this is going to be 2/9 x, and this is going to be 7/3. So 2/9, oops, I left out the x. So 2/9 x. Okay, so add in the x right here, plus 7/3, and 2/9 x minus 7/3. All right. For C, if you want to pause it and try these, you can try these on your own and then, play the video to check your answers. 4x squared minus 25. So that's going to be 2x minus 5 and 2x plus 5. Okay, these are both perfect squares. 4 is a perfect square, and x squared is a perfect square. 2x times 2x is 4x squared. 5 times 5 is 25. And then D is not much different, except I have a number in front. I don't have the x squared or anything, a letter in front. But 16 is a perfect square, 4 times 4. And 81 is a perfect square, 9 times 9. And x squared is a perfect square. So it's 4x minus 9x and 4x plus 9x. Okay, we're going to try some more on the next page. So we're going to, in this exercise 3, we're going to use a combination. The first step when you're factoring is look for the greatest common factor if there is one. And then we're going to do greatest common factor and difference of perfect squares. So write each of the following in its completely factored form. So that right there is giving you a clue that you're going to have to do more than one thing. So I look at this 5x squared minus 20. You're looking for the greatest common factor. The greatest common factor that both of these terms have in common is a 5. So I'm going to factor out a 5. Now think about what's left when you factor out a 5, when you divide by 5. 5x squared divided by 5 is x squared. Negative 20 divided by 5 is negative 4. Now I'm not done factoring because this right here in the middle is the difference of two perfect squares. So the 5 is going to stay in front. I'm going to set up my two parentheses because these I'm going to multiply. These are going to factor x squared is a perfect square, x times x, and 4 is a perfect square, 2 times 2. One's a plus and one's a minus. So this is the completely factored form right there. If I was to multiply this all out, I would get 5x squared minus 20. You can always check these and multiply them to see if you get the answer that you started with. All right, so if you want to try B and C, and then you can start the video again to check them. But in each of these, you're going to look for the greatest common factor, and then you're going to do the difference of two perfect squares. So 28x squared minus 7, the greatest common factor is 7. 28x squared divided by 7 is 4x squared, and negative 7 divided by 7 is negative 1. Now, you might not recognize this, but 1 is still a perfect square. 1 times 1 is 1. 4x squared is a perfect square. 2x times 2x is going to be 4x squared. So I write my 7, the number I factored out, my greatest common factor, and now I take this 4x squared minus 1 and I write my two parentheses. 2x minus 1 and 2x plus 1. Okay, 4x squared is a perfect square, 2x times 2x, and 1 is a perfect square, negative 1 times 1 is negative 1. And same thing on C, except this time I'm going to have a number and a letter that I'm going to be able to factor out. The greatest common factor for 3x cubed minus 48x is 3x. Now when I factor out a 3x, I'm left with x squared. And when I factor out a 3x from negative 48x, I'm left with negative 16. So the 3x is the greatest common factor. X squared minus 16 is what's left. This is the difference of two perfect squares. So my 3x stays in front, and I set up my parentheses, x squared minus 16, and that factors to x minus 4 and x plus 4. Okay, before we start doing some trinomials, let's just start try multiplying these. All right, because actually factoring is just a reverse. So if you're comfortable with this multiplying, then you will be comfortable factoring, because we're going to factor trinomials down in exercise 5. So exercise 4, all I'm doing is writing the products in simplest ax squared plus bx plus c form. So what I'm actually doing is, your teacher might have taught you this as foiling, doing the distributive property twice, but 3x times 5x, 3x times 7, 2 times 5x, and 2 times 7. So basically FOIL, first, outers, inners, last, your teacher might have taught you. All right, so 3x times 5x, that's the first term. 3x times 7, that's the outside term. 2 times 5x is the inside term. And 2 times 7 is the last term. So 3x times 5x is 15x squared. 3x times 7 is 21x. 2 times 5x is 10x. And 2 times 7 is 14. You're always going to get two terms, and these two middle terms you'll be able to combine together, because 21x plus 10x is just going to be 31x. So I have this in, now this is a trinomial. Trinomial means three terms. This is in my ax squared plus bx plus c form. 15x squared plus 31x plus 14. So basically, you're going to do that for B and C. So why don't you try doing that? Pause the video, and you can try that. And again, you're foiling 2x times 2x, 2x times 5, negative 3 times 2x, negative 3 times 5. And then the same thing on C, 5x times x, 5x times negative 2, negative 4 times x, and negative 4 times negative 2. So pause the video, try those, and then check your answer. 2x times 2x is 4x. There was 6x squared. That should be 4x squared. So let me fix that. All right, so this is 4x squared. 2x times 5 is going to be 10x. Negative 3 times 2x is negative 6x. And negative 3 times 5 is negative 15. You get four terms, and these two middle terms I can combine together. And I'm probably going to have to fix this down here too. At least I was consistent and made the same mistake twice. This should be 4x squared plus 4x minus 15. Again, those two middle terms get combined to give me 4x. Positive 10x and negative 6x is positive 4x. And now this is a trinomial. And then C, 5x times x is 5x squared. 5x times negative 2 is negative 10x. Negative 4 times x is negative 4x, and negative 4 times negative 2 is positive 8. Those two middle terms I can combine together, and negative 10x and negative 4x is going to be negative 14x. So now I have my trinomial. Now I'm going to factor my trinomial. So really I am starting with the trinomial and I'm working backwards and setting up my two sets of parentheses. So for each of these, I've already set up my two sets of parentheses. Now what you do, x squared, what happens is x and x are going to go in the first term right there. X times x is x squared. Now the numbers that go in the second term multiply to 35 and combine together to give me 2. So you can actually list the factors of 35 and you can see which ones will combine together. I say combine because you might be adding them, you might be subtracting them. But the numbers that multiply to 35 and will combine together to give me 2 are 7 and 5. Now for 7 and 5, they multiply to 35. How are they going to equal positive 2? Well, if it's a positive 7 and a negative 5. Okay, so that's how I do this. I don't worry about the signs until the end, until afterwards. So same thing here, x squared. Well, that's going to be x times x. That goes in the first term. What numbers multiply to 24 and add up to 11? Okay, so you can think, all right, 1 and 24, they don't add up to 11. 2 and 12, they don't add up to 11. 3 and 8, oh, 3 and 8. 3 and 8 will give me 11. And now check the signs. The only way 3 and 8 give me 11 if it's a positive 3 and positive 8, and this is positive 24, so perfect. All right, so like back here, and I don't know why I wrote 11 there. I'm making lots of mistakes. That should be a 3. So this we're going to fix to a 3. I just wanted to mention that like back here, this was a negative 35. So one of these had to be positive and one of them had to be negative. If the last term is a positive, they're both the same. They're both positive or they're both negative. Like on C, x times x is x squared. So that's the first term. What numbers multiply to 22 and combine to negative 13? Well, 2 and 11 multiply to 22, and can 2 and 11 give you a negative 13? Absolutely, if it's negative 2 and negative 11. All right, and when I'm multiplying negative 2 and negative 11, that gives me a positive 22. So multiply gives you a positive 22, and when you're adding those inner and outer, so basically what you're doing is when you were FOILing up above, these were getting multiplied. So that negative 11x and negative 2x is giving me that negative 13x. So that's what's going on. And in D, same thing. It's going to be x times x. We'll do some that have a number in front also. But x times x is x squared. You're looking what numbers multiply to 50 and combine together to give me negative 5. So you're thinking the factors of 50, 1 and 50, 2 and 25, 5 and 10. Oh, 5 and 10 can give me a negative 5. How are 5 and 10 going to give me a negative 5? If it's a negative 10 and a positive 5. Okay? And here are some that have a number in front. They have a leading coefficient, so I have to be careful on these. The only way I'm going to get 3x squared is if I have 3x times x. Now you have to be careful because I have to come up with the factors that multiply to 40 and add up to 19. But whatever number you put in this spot right here is technically being multiplied by 3. Because when I am FOILing, right, the number that goes here is getting multiplied by 3. So you have to be super careful. So you're really just playing around with these factors. So 2 and 20, and you have to try them out in both positions. So I have like 2 and 20, and then I have 4 and 10, and then I have 5 and 8. And you have to try the 5 here and the 8 here and the 8 here and the 5 here. So it's really just guessing and checking, I think, is the easiest way that I prefer to do that. Now 2 and 20, no matter if I put the 2 here, the 20 here, or the 2 here, and the 20 there, are never going to give you a 19. The one that works is 5 and 8, but you have to be careful where you're putting the 5 and where you're putting the 8. So this is going to be, I have my answer here. It disappeared. Oh, there we go. Negative 5 times x is negative 5x, and 8 times 3 is 24x. So 24x and negative 5x will give me that positive 19. So it's super important when you have a coefficient where the numbers actually go. All right, so if you want to pause the video and try B, you can try B. So this one I have 2x times x is 2x squared. And then again, I'm just thinking about my factors of 18. So obviously I have 1 and 18. I have 2 and 9. I have 3 and 6. And that's about it. So I just have to play around with all of these in both positions to see which one will actually work. Again, you have to be careful to make sure that whichever number that you're putting in this second position, recognize that it's being multiplied by 2. Okay, so this one is going to be 3 and 6, and negative 3 times x is negative 3x, and negative 6 times positive 2 is going to be a negative 12x. So that's why together these give me a negative 15x. All right, so this is not part of the answer. This is just me showing you how I multiplied. This is what I'm doing in my head to show you that that works. Okay, now that we've done a little review of factoring, we're going to move on to solving a quadratic equation. Okay, so on this next page, we're going to solve a quadratic equation, which involves factoring. So we're going to take everything that we just learned, okay, and we're going to solve equations with it. So you did this back in algebra. You're going to do it again in algebra 2. So I'm going to review how you did it in algebra, and then we're going to do some geometry problems with it. So the first step is that you have to get the equation in standard form. That means that everything has to be on one side, and you set it equal to 0. So if it's not in standard form, you first have to move everything so that everything's on one side and you have 0 on the other side. Normally we move it to the left, but it really just doesn't matter. Step 2 is you have to factor if possible. Always look to see if there's a greatest common factor, if it's a difference of 2 perfect squares, if it's a trinomial, you just set up your 2 sets of parentheses. Then you set each factor equal to 0, and then you solve each resulting equation. So let's look at how you did it back in algebra. So x squared plus 3x minus 14 equals negative 2x plus 10. So I want to bring everything over to one side. So I'm going to take this negative 2x and I'm going to subtract 2 and add 2x, and I'm going to take this positive 10 and I'm going to subtract 10. Whatever I do to one side, you have to do to the other side. So on the left side, I have x squared, 3x plus 2x is 5x, and negative 14 and negative 10 is negative 24. On the right side, these all cancel, which was my intention, and I have 0. So I did step 1. I said everything, put it in standard form, everything's equal to 0. Step 2 is I'm going to factor. So this is a trinomial, there's no greatest common factor. I set up my 2 sets of parentheses. X times x is x squared, okay? I'm looking for the numbers that multiply to 24 and add up to 5. So I'm thinking of my factors that multiply to 24. I have 1 and 24, 2 and 12, 3 and 8, 6 and 4. The only ones that are going to combine together to give me 5 are a positive 8 and a negative 3. Okay, 8 times negative 3 is negative 24, and 8x and negative 3x is a positive 5x. Now, step 3, I set each factor equal to 0. So x plus 8 equals 0, x minus 3 equals 0. And then I'm going to solve. The only thing that happens when I solve is the signs change, because I need to get x by itself, so I subtract 8 from both sides, and I get x equals negative 8. I have to get x by itself, so I add 3 to both sides, and I get x equals 3. So I have 2 answers right there. Okay. B, again, I'm doing the same thing. I need to solve. So I need everything on one side. So I'm going to bring this x squared over to the other side, bring the 3x over, bring the negative 2 over. So I'm going to subtract x squared. I'm going to subtract 3x. I'm going to add 2. 3x squared minus x squared is 2x squared. 12 minus 3 is 9x, and negative 7 plus 2 is negative 5. I then have to factor this. Now, this one's a little bit harder to factor. 2x times x is 2x squared. I'm looking for numbers that multiply to 5 and add up to 9. It's not too hard because there's only one set of numbers that multiply to 5, 1 and 5. But it is important where you're putting them, because the only way you're going to get a positive 9x is if the 5 goes here. Because I need the 5 in this spot right here, because 5 times 2x is 10x. Okay, so again, the 5x times 2x, oh, let me get a colored pen right here. The 5 times the 2x is 10x, and then negative 1 times x is negative 1x. Together, those will give me a positive 9x. So you do have to be careful when you have a coefficient where that number is going. The next step is you take each of these factors, set them equal to 0, and then you just solve. So I'm going to add 1 and divide by 2, and I get x equals 1/2. And then I'm going to subtract 5, and I get x equals negative 5. So that's what you did back in algebra, and I just wanted to review that. And we're just going to practice some geometry problems with factoring right now. So I'm not giving you the equation. You have to come up with the equation on your own. So we can try some of these together, and then when you get comfortable with it, if you want to pause the video and try some on your own and then check them, that would be great. So number 1, I have M is the midpoint of AB. So that's my key word right there. M is the midpoint. If M is the midpoint of AB, it cuts AB in half. So AM is now congruent to MB. So my equation is just to set AM equal to MB. I'm going to set 10x equal to 5x squared. Now this is not going to result in a trinomial, so it will be a little bit easier to factor. I want to keep my x squared positive. I know normally I bring everything over to the left. It's absolutely okay to bring everything over to the right. So I'm going to subtract 10x. So I'm going to have 5x squared minus 10x. It's not a trinomial, so I'm looking for my greatest common factor. All right. My greatest common factor is a 5x. So I factor out the 5x, and I'm left with x minus 2. I still do the same thing, even though it wasn't a trinomial. I factored out my greatest common factor. Now I set each factor equal to 0. So I'm going to set 5x equal to 0, and I'm going to set x minus 2 equal to 0. And then I just solve. Well, when I divide by 5, x just equals 0. I add 2, x equals 2. Now, the thing with this is you have to be careful in geometry. Sometimes a negative answer or an answer like 0 makes this not work, because 10 times 0 is 0. You can't have the length of a line being equal to 0. So I don't erase the answer, but I just put a line through it. I'm not going to use that answer. I'm just going to use x equals 2. So it is important in geometry to sort of take that negative answer or take that 0 and plug it in and just check that it results in a positive answer for the length of a line or for a positive answer for an angle. Okay. 9 already has the picture for us. So I have angle 2, which is right here, is 3x squared minus 8x plus 5. And then I have angle 4 is 4x plus 5 over here. Angle 2 and angle 4, if you remember, those are called vertical angles. Vertical angles are opposite each other. They're equal to each other. So I'm going to take the 3x squared minus 8x plus 5, and I'm going to set it equal to 4x plus 5. All right, these are vertical angles. Vertical angles are equal, so you set them equal to each other. So now that I have the equation, I'm just back looking at my steps that I have at the top of the page. I want to have everything on one side. I want to set it equal to 0. So I'm going to take the 4x and I'm going to subtract it. I'm going to take the 5 and I'm going to subtract it. Now, when I do that, I actually, I subtract 4x and I get negative 12x, but when I subtract 5, those 5s cancel. So actually, this is not a terrible one because it's not a trinomial. I'm just factoring out the greatest common factor. All right? So the greatest common factor, look at the numbers. The biggest number that's in common is 3. Look at the letters. The biggest letter that's in common is x. So my greatest common factor is 3x. Now, when I factor out that 3x, I'm left with x minus 4. I then set each factor equal to 0. So I have 3x equals 0 and x minus 4 equals 0. And then I'm just solving. Okay, so when I solve for x, I divide by 3, I get x equals 0. When I solve for x, I add 4 and I get x equals 4. All right, so now that you got the idea, if you want to try a few on your own, the first one that we have on the next page is a little bit different in that it's a right triangle, so you're going to use the Pythagorean theorem. But if you want to try a few on your own and then check them, that would be great. All we're doing is just taking different things that we've learned in geometry this year, and they will result in problems that you have to factor after you set up the equation, right? So flipping this over, as I said, this first one right here, I'm solving for x. These are the three sides of a right triangle. So I'm going to use Pythagorean theorem. A squared plus b squared equals c squared. So x squared plus x minus 2 squared equals 10 squared. Now this x minus 2 squared you have to be careful with. X squared is just x squared. 10 squared is just 100. But x minus 2 squared is technically x minus 2 times x minus 2. So I'm doing it right up here. I did it down here sort of in my head, but I'll do this, show you up here what's really happening. So when you're multiplying this, I have x minus 2 times x minus 2. I have x times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. And negative 2 times negative 2 is positive 4. All right, so x squared stays x squared. This x minus 2 squared, and I'll just highlight that, actually is x squared minus 2x plus 4. And I got it from foiling up here. And again, the 10 squared was just 100. Now I'm just going to combine the negative 2x and the negative 2x get combined. Remember, whenever I have this, I get 4 terms and those 2 middle terms combined together. So negative 2x and negative 2x is negative 4x. I can also combine this x squared and this x squared right here. So that's all I'm doing on this next step is I'm going to combine x squared, and I'm going to combine negative 2x and negative 2x. And I'm actually going to bring this 100 over to the other side as well. So x squared plus x squared is 2x squared. Negative 2x and negative 2x is negative 4x. And if I subtract 100, that gives me negative 96. Now, this is a trinomial, but I actually have a greatest common factor, and that will make it a lot easier to factor because factoring when I have a coefficient is a little bit trickier. But all of these numbers are even numbers, so I can factor out a 2. When I factor out a 2, I'm left with x squared minus 2x minus 48. You're essentially dividing out a 2. Now, this is just a normal trinomial that you can factor. X squared minus 2x minus 48, right? It's just a normal everyday trinomial. When I factor that, I have the 2 stays in front. I'm thinking about what numbers multiply to 48 and add up to negative 2. So the factors of 48 that will give me negative 2 as a middle term are 6 and 8. Now the 2 hangs out in front. It's got to be a negative 8 and a positive 6 because they multiply to negative 48, but they combine together to give me a negative 2. So if it's a negative 2 in the middle, my bigger number has to be negative. So it's 2 parentheses x minus 8, x plus 6. Now the 2 sort of drops off, and all I do is I set each of these factors equal to 0, just like I was doing before. So x minus 8 equals 0, and when I solve, I get x equals 8. and x plus 6 equals 0. And when I solve, I get x equals negative 6. Now, I can't have x equal to negative 6 because when I plug it in, that would result in the side of the triangle being negative, and it can't be. So I'm going to just put a line through that answer, and my answer is x equals 8. Okay? 11, your paper has different numbers, so I am going to need you to change your numbers on number 11. So it should be x squared minus 4 and 3x plus 14. The way that the numbers that we had weren't coming out, they weren't factorable. All right, so I'm going to change that. K is bisecting the line segment. If this line K is bisecting the line segment, that makes M a midpoint, and that means it's dividing this line segment in half. So 3x plus 14 equals x squared minus 4. Remember, you're changing the numbers that were in the original problem. But it's a bisector, so it's dividing it in half. So x squared minus 4 equals 3x plus 14. Now I want everything on one side. So I'm going to subtract 3x and I'm going to subtract 14. That will result in x squared minus 3x minus 18 equals 0. All right, so everything's on one side. Now I have to factor it. I'm thinking what numbers multiply to 18 and will also add up to negative 3. Well, the numbers that multiply to 18 are 1 and 18, 2 and 9, 3 and 6. And the only numbers that will give me negative 3 as a middle term are that 6 and 3. So I'm going to set up my parentheses. X times x is x squared. I already said 6 times 3 is 18. How is it going to give me negative 3 as a middle term? Is if it's negative 6 and positive 3. It is important with the signs. Now I set each of these factors equal to 0. So I'm going to have x minus 6 equals 0, and that would result in x equal to 6. And x plus 3 equals 0, and that would give me x equals negative 3. Now you just have to be careful with that negative. When I plug in a negative, you're just checking. 3 times negative 3 is negative 9, plus 14 is 5. So that's okay. And then just check this side. Negative 3 squared is actually positive 9, and 9 minus 4 is 5. So both these answers work. So you are all set. You can keep them both. You're just checking to make sure that negative resulted in the length of the line being a positive, and it does. All right, number 12, I have a triangle ABC. So angle ABC, which is right here, is x squared. Angle BCA, which is right here, is negative 6x plus 100. And angle CAB, which is right there, is x plus 56. Now think about what you know about the three angles of a triangle. Well, the three angles of a triangle equal 180. So I'm going to take all of those angles, x squared, the negative 6x plus 100, and the x plus 56, and I'm going to take them and I'm going to add them and I'm going to set them equal to 180. So each angle, here's one angle, here's two angle, here's the third angle, all three angles, and I add them and I set them equal to 180. Now, these x's can be combined right here. Negative 6x and x is negative 5x. I'm also going to combine the 100 and the 56 together. So I'm going to have x squared minus 5x plus 156 equals 180. So I combined all those like terms together. I still have to get this with everything on one side. So I have to take this 180 and I have to subtract it. So I'm going to have x squared minus 5x minus 24. 156 minus 180 is negative 24 equals 0. Once I have everything on one side, now I have to factor. So there's no coefficient, so it's not too bad. X times x is x squared. I'm thinking of the numbers that multiply to 24 and combine together to give me negative 5. So 24, I got 1 and 24, 2 and 12, 3 and 8, 6 and 4. The only numbers that are going to give me a 5 as a middle term are the 3 and the 8. And in order for it to be negative 5, it's going to have to be negative 8 and positive 3. So negative 8 times 3 is negative 24. And when I check this out, my negative 8x, negative 8 times x is negative 8x, and my positive 3x would give me that negative 5x as a middle term. So once I have it factored, I set each factor equal to 0. So x minus 8 equals 0, which results in an answer of x equals 3. And x plus 3 equals 0, which results in an answer of x equals negative 3. Now they want me to find the measure of angle ABC. So angle ABC is x squared, and 8 squared is 64, right? I actually, not looking at this, if I plugged in negative 3, for that, negative 3 squared is 9. That also would have worked. Okay, so technically there are two answers for that. A lot of times in geometry, we are just using that positive answer because it results in an answer that doesn't work, the negative one, but in this particular case, they both work. All right, so 13, we have to remember our rules for parallel lines. And if I have two lines that are parallel, these angles right here are alternate interior angles. Alternate interior angles are congruent to each other. So x squared plus 8x equals 3x plus 6. They're alternate interior angles. So the hard part, the geometry part, is just setting up these equations, and then from there on, it's what you learned in algebra next year, and you will go on next year in algebra 2 to do these more in depth. Okay, so they become a little bit harder, more involved. Step 1, I want to get everything on one side, so I'm going to subtract 3x, and I'm going to subtract 6, and that's going to give me x squared plus 5x minus 6. Now with 6, you do have to be careful because the factors of 6 are 1 and 6 and 2 and 3, and both of those will give me 5 as a middle term depending on the sign. So you really have to be careful with the 6 and the 5 combination. In this particular case, this is a negative 6, so I need my numbers to be, one of them to be positive and one of them to be negative. So I can't use the 2 and 3 because my signs have to be different, and my middle term is a positive 5x. If my signs for 2 and 3 are different, they're never going to give me a positive 5x. But look at the 6 and the 1. 6 times 1 is negative 6, but it gives me a positive 6x and a negative 1x as a middle term. That would give me that positive 5x. Then I set each factor equal to 0. And as you can see, all that's been happening when I do that is the signs change. X plus 6 equals 0, so x equals negative 6. X minus 1 equals 0, so x equals 1. Okay? If I plug in this negative answer, that would make that not work. So actually, x equals 1 is my answer. Okay, so I am just checking. The negative does not work. All right, so if you want to try the second one on your own, if you haven't been trying any on your own, now's the time to do that, and then you can check your answer. They're also alternate interior angles, so you can pause the video, try it, and then restart it. Okay, so these are alternate interior angles. I'm just going to set them equal to each other. So now I'm going to bring everything over. So I'm going to subtract this 4x squared, and that gives me x squared. But I notice that this is a perfect square. If I was to bring this over to the other side, that's going to give me a positive 100. You can bring the 75 over and you have x squared minus 100, which is the difference of two perfect squares. It will give you the same exact answer. Now to solve for x, I take the square root of 100, which is positive 10 and negative 10. In this particular case, so I'm just going to keep that positive answer. Okay, and then I have a few more to try on that next page. I got 4 more to try. So if you want to try them on your own, you can do that. So these are all just different things that we've learned. So in 14, so I have the sides and these lines are parallel, therefore the sides are in proportion. So 14, you're going to set up a proportion if you want to try this on your own. 15 is the area of a rectangle, which is base times height, length times width. 16, that exterior angle of a triangle is equal to the sum of the two remote interior angles. So this angle equals 4x plus 2 plus x plus 6. And in 17, I have complementary angles. Complementary angles equal 90. So pause the video, see if you can set up those equations, and then I will just then start it and you can check your answers. As I was saying on 14, these lines are parallel. Therefore, those sides are in proportion, because if the lines are parallel, that makes these angles congruent, which makes the triangle similar. This smaller triangle is similar to this bigger triangle. So I just take the two sides on the left, 10 over x, and I write them. And then the two sides on the right, x plus 7 over 6. Now, the way that I solve a proportion is I cross multiply. So x times x plus 7, you're actually multiplying it by the whole thing. X times x plus 7 is x squared plus 7x. 10 times 6 is 60. Now I'm right back where I started. I want to bring everything to one side, so I'm going to subtract 60. And I'll have x squared plus 7x minus 60 equals 100. Then I have to factor, so I'm looking for the numbers that multiply to 60 and add up to 7. All right, so if you think of my factors that multiply to 60, and I see that I have a mistake here. I'm just looking at this. 10 and 6, 15. I'm just thinking of what my factors are. 10 and 3 do not multiply to 60. That's what I had on my paper right there. So that's a mistake. So let me think what multiplies to 60. 6 times 10, that doesn't work. 15 times 4, that doesn't work. 3 times 20, that doesn't work. 20 times 3, no, I said that one already. I'm thinking that I have a mistake in this problem, so this mistake is not doable. This problem is not doable. Okay, so this isn't factorable. So this is wrong right here. So forget about this. And we can't factor that. All right, sorry about that. So moving on to 15. Area of a rectangle is 60. So area is length times width. So basically 4x plus 4 times x minus 1 equals 60. So 60 is the area, the length is 4x plus 4, the width is x minus 1. So 4x times x is 4x squared. 4x times negative 1 is negative 4x. 4 times x is 4x, and 4 times negative 1 is negative 4. Okay, so the 60 I'm just bringing down. 4x times x is 4x squared. 4x times negative 1 is negative 4x. 4 times x is positive 4x, and 4 times negative 1 is negative 4. Now, these two middle terms are actually going to cancel out, okay? And I'm going to bring this 60 over to the other side, which will become negative 64. So this is 0 because I subtract 60, and I have 4x squared. These cancel out right here. And then I subtracted 60, negative 64. Now, there's a greatest common factor, and that greatest common factor is 4. So I factor out of 4, and I'm left with x squared minus 16. Now, this is the difference of two perfect squares. Remember, it's going to be x minus 4 and x plus 4. So the 4 is hanging out in front, and the two factors are x minus 4, x plus 4. I then take each of these factors, you ignore the 4 in front, take each of these factors and set it equal to 0, and that just results in x equals 4 and x equals negative 4. Now, x equals negative 4 cannot work because when I substitute that in, negative 4 minus 1 results in negative 5, and the length of that side of the rectangle cannot be negative 5. And they want me to find the length and the width, so I'm not sure if I wrote that right here. The length is going to be, length is 4 times 4 plus 4, because it's 4x plus 4, and now I know that x is 4. So 16 plus 4 is 20, and the width is 4 minus 1, which is 3. Okay, number 16, the exterior angle of a triangle is equal to the sum of the two remote interior angles. So this x squared plus 3x is equal to 4x plus 2 plus x plus 6. All right. I combine these. 4x plus x is 5x. 2 plus 6 is 8. So x squared plus 3x, there's nothing to combine on the left. 4x plus x on the right is 5x. 2 plus 6 on the right is 8. Now I want to move everything to one side, so I'm going to subtract this 5x. I'm going to subtract that 8. So 3x minus 5x is negative 2x. And then I subtract 8 on that side. All right, so now I have a trinomial. I have to think of my factors. What numbers multiply to 8 and add up to negative 2? So the numbers that multiply to 8 are negative 4 and positive 2. And I want the 4 to be negative because I need this to be a negative 2 in that middle term. So x minus 4, x plus 2. 4 times 2 is negative 8, and negative 4x and positive 2x is a negative 2x. Then I set each answer equal to 0. So that gives me x equals 4 and x equals negative 2. Now, quickly checking, if I was to plug in negative 2, it works here, but here it doesn't. 4 times negative 2 is negative 8, and negative 8 plus 2 is negative 6. So you have to make sure that the negative would work in all the problems, and it does not. So my answer is just x equals 4. Okay, and then this last one, angle 1 and angle 2 are complementary angles. Remember, complementary angles are angles that add up to 90. So angle 1, which is x squared plus 10, plus angle 2, which is negative 16x, together they equal 90. So x squared plus 10 plus negative 16x equals 90. Now I'm just going to rearrange this so that it's in standard form, x squared minus 16x. I'm also going to subtract that 90 from the other side. Okay, so that's going to give me x squared minus 16x minus 80. So standard form is to write this 16x second, and then I subtracted 90. 10 minus 90 is negative 80. Now I'm trying to find the factors that multiply to 80 and that add up to negative 16. So the numbers that multiply to 80 are 20 and 4, and I want them to equal negative 16. Okay, so the only way they're going to equal negative 16 is if it's negative 20 and positive 4. Right, so again, negative 20 times positive 4 is negative 80, and negative 20x and positive 4x would give me my negative 16x. And then I set each of these equal to 0 and solve, which just results in the signs being different. So that gives me x equals 20, and this gives me x equals negative 4. And this one, they want me to find the angles. So I'm going to substitute in for my angles. Now this one, the 20 is the one that does not work. If I plug in 20 for x squared, 20 squared is 400, and 400 plus 10 is 410. That's impossible. All right, so in this particular case, it's the negative answer that works. So angle 1 is negative 4, squared is 16 plus 10 is 26, and angle 2 is negative 16 times negative 4, which is positive 64. So that was a little tricky in terms of the answer. Okay, and that's it for our factoring.